We have an example. So given a data set of student scores in math and physics, assess whether there is a linear relationship between their performance in these two subjects. So the data is given as below. We have student A, student B, student C, student D, student E. Then you have the math score, you have the physics score. So if they are saying you assess whether there is a linear relationship between their performance in these two subjects, then we are going to use the Spearman rank correction coefficient. We are also going to use Pearson's product moment correction coefficient. So let us begin with, so to assess the existence of a linear relationship between the two scores, between the two subject scores. So what you have to understand, we will use one, Spearman rank correction coefficient, and then two, we shall use Pearson correlation coefficient, or what we called the Pearson product moment correlation coefficient. Good. So we have x. So when we put values of x here, we need to get the rank of x. We need to get x, maybe minus x bar. Then we need to get y. Then we get the rank of y. Then we need to get y minus y bar. Why am I doing this? I'm just doing a table that is going to help us try for Pearson, but also do for Spearman's rank correlation coefficient. So I have math, which is x, 90, 75, 60, 85.
And the D?
Yes, 90, 60, 90, 75, 60, 65. So we have that information now. The struggle is to get the rank, and then get those other values. So when you look at the values here, which one is the smallest? The smallest is 60. So I will give it 1. Yes.
Yeah, 60.
The next one,
Five.
is 75. So I give it 2. The next one is
85.
85
85, which is 3. The next one should be here,
is
4
90.
and 5. Okay. Then I also need to get the rank here. The smallest is 65.
70.
Is number 2,
Then 80.
3, 4.
85.
Wow. This is going to be, I think I need to interchange somewhere, somehow. Let me make this. I want to change something here. So that D is going to be, get D. D is, after getting D, we need to also get D squared. So this D, you get any of the, you get the rank for X, you subtract the rank for Y, you write. So what is that? I want to get 5 minus 4, you'll get 1. I get 2 minus 2, I get 0. So this becomes 1, this becomes 0. 1 minus 1 is 0. I get 0. Then 4 minus 3, I get 1. I get 1. Then 3 minus 5, I get negative 2. I square, I get 4. I needed to get the sum of these ones, so that I get, I get the average. So let me get 95. Now, this one I said to get x bar, sum x, then divide by n. This was 355 divided by 5, and that's what you get. Then for this one, also for y, we have 90 plus 80 plus 135 plus 85. So here we have also sum of y is equal to 390. So y bar should give you 390 divided by 5. And we have 78. So here I get 95 minus 78. No, 95 minus 71 for this. So 95.
24.
You get?
24.
You get 24. 60 minus 71, you get negative 11. This one you get negative 21. This one you get 9. This one you get negative 1. For this, 85 minus 78.
13.
You get 13. 70 minus 78, negative 8. 65 minus that, you get negative 13. Is it? Or 20? I think
Negative 13.
Negative 13. Then this one, 80 minus that, you get 2. 90 minus that, you get 12. So that is done. So if that is done, you can sum this. So So when I sum here, what will that be? Okay, so let's write our Spearman's rank correction coefficient is equal to 1 minus 6 sum of d squared divided by n into n squared minus 1. But what is n? N, I will say the n is going to be the number of data points. So which is, this is 5, okay? So there are 5 data points, and this is going to be 1 minus 6 times 4 divided by 5 into 25 minus 1. So this is
Times
1,
6. Isn't it times 6?
this times 6. 6 sum of d squared, isn't it?
Yeah. D squared, isn't it 6?
The sum, okay. That sum should be 6. Let's write it properly. Sum of d squared, okay? So that value should be 6. So that is 36 divided by 5 times 24. 36
That's 100.
divided by, is it 100?
Yeah, it's 100.
Divided by 5 divided by 24. So 1 minus answer 24 divided by 5. Okay, should be 120. So 36 divided by 120, you get that. So 1 minus 0.3, you get 0.7. So there is a moderate linear relationship. So moderate. Though you can say it is moderate or substantial. Moderate linear relationship. Another one can say substantial because 0.7 is above 0.5. Substantial. So when we use Pearson product moment, Pearson's product moment correlation coefficient. So that R is equal to SYX divided by square root. Okay, this is the formula that you can always also find. So SX times SY. But SYX is the same as sum of X minus X bar times Y minus Y bar. Then you also find that SXX is equal to sum of X minus X bar squared. Then you also find that there is SYY, which is equal to sum of Y minus Y bar, everything squared. When you put that together back in that formula, R is equal to sum of X minus X bar into Y minus Y bar. This is supposed to be square root. Okay, so you'll find you have root of sum of x minus x bar squared times square root of sum of y minus y bar squared. So we go back and see maybe which relation don't we have? Probably it's the square that we may not be having. Okay, so that means you need square this, we need square that. We are saying let us get those values. 24 times 13, we have 3, 1, 2. Then negative 11 times negative 8, obviously it has to be 88. What else? Also get negative 21 times negative 13. Negative 21 times negative 13. We get 273. Then 2 times 18 times 2, 2 times 9, we get 18. So here we have 273 and we have 18. What else? It's negative 1 times 12, which is negative 12. So get a negative 12. Okay. I hope there is no other that we have left behind. Then the other ones are squaring this, squaring that, and we sum. So 24 squared plus 11 negative squared plus 21 squared, which is negative, plus 81, which is 9 squared plus 1. So we are supposed to also write sum of x minus x bar squared. We are getting 1220. Sum of y minus y bar squared. We are supposed to sum. So let's sum. We have 13 squared plus 64. Remember, any negative number squared is always a positive. So the negative times a negative always gives a positive. You should be able to look at that. Then 13 squared again plus 4 plus 12 squared. So we are getting 550. 550. So finally, our R will equal to, what is this? The sum of this. 3, 12 plus 88 plus 273 plus 18 plus negative 12 minus 12 plus 18 plus 273 plus 88 plus 312. We have the total here, sum of that, x minus x bar into y minus y bar, equivalent to 679. So our R will equal to sum of that, x minus x bar into y minus y bar, divided by square root of sum of x minus x bar squared times sum of y minus y bar also squared. Remember, all of this is under root. So what are these values? We have 679 divided by square root of, okay, let us put them down here. R will equal to 679 divided by 20 times 550. What we are getting is 0.829, which is also shows you that there is therefore a significant stock substantial linear relationship between the scores in math and physics. So you can see Pearson gives us 0.829, but Spearman's rank correction coefficient gives us 0.7, which is at least they are all agreeing on the same conclusion, though they are giving different levels of the relationship, the levels of strength of the relationship. So key things to note is that if you are doing for Spearman's rank correction coefficient, then you don't need the x minus x bar and the y minus y bar. You only need the rank for x, the rank for y, then d, which is the difference between the ranks, and the square of the ranks. Then you will be in a position to use this formula for Spearman's rank correlation coefficient, 1 minus 6 sum of d squared divided by n into n squared minus 1. You get the value for Spearman's, and then you comment the importance or the meaning of that value that you have obtained. Then for Pearson's product moment correlation coefficient or the Pearson's correlation coefficient, you need to get x minus x bar. You also get y minus y bar. Of course, you need to square them. Then you don't need the rank for y, you don't need the rank for x. Then you also don't need the d and the d squared. So I did this because I wanted to do one table and then answer give an answer for the different parameters for measuring the strength between the two variables or between the two performances.